So I would want to welcome all of you here to the last two topics on the foundational forecasting. We have looked at 5 forecasting techniques potentially already. The first is the naive forecasting, also called random walk, which is where you focus mainly by using the past. The second is a simple average forecasting. You take the average of everything. Okay. Everything at the point at which you are looking at. So if you're looking at year 1, you're looking at the average of year 1. If it's year 2, you're looking at the average of year 1 and 2. If it's year 3, you're looking at the average of 1 and 3, 1, 2, and 3. And then we looked at the moving average. So that one is the same as this simple average, but the specific moving average is given. Either 3-month moving average, 4-month moving average, 6, 7, or whichever month moving average. And then we looked at weighted moving average. So specific weights are given to each of the actual values. Okay, if it is sales, each of the sales. And then from that, we looked at the simple exponential smoothing, which depends on levels, but it does not depend on trend, and it does not depend on season. What we are going to look at today is double. You see, the simple exponential smoothing is also called single exponential smoothing. Single, because it only depends on the levels as well as, of course, the errors. Today, we want to look at the double exponential smoothing postulated by Holt. And then we'll look at the triple exponential smoothing postulated by Holt Winter. So I would encourage you to pay attention, but more importantly, ask questions so that you can understand whatever we are going to do. If you are ready, just type yes, and let me be sure that you are ready. Just type Y or yes. Okay. Or say it so that I know that you're ready. I'm trying to go a bit slow so that the others will be able to join us. Class rep, ensure that everybody is aware that we started. Let's begin. So by the end of this course, you should be able to apply, interpret, and compare the time series. As you guys have already told me, I do not want to bore you so much with a Python, but I will always give it to those, not here, but also I give it to those that need it. Because in your practical dissertation, that is easy to use. So Holt's double exponential smoothing relies on trend as well as level. I'll explain that. And the Holt Winter looks at both trend, level, as well as season. We are going to use our small data set to demonstrate these two experiments. They are very, very popular, and they are very good because there are so many things in them that if your data has those behavior, it can capture them. Now, as we speak today, there are so many papers published, peer-reviewed papers, very recent ones actually, very, very recent, that have applied these, which means that you can apply this to your dissertation. You can apply what we are going to do today to your thesis. Whether it's a master's thesis, a PhD thesis, you can apply. Because these are published in reputable journals. For example, the first one, Al-Araj is published in the Journal of Applied Statistics, just 2021. Applied Soft Computing, okay, published by Pradeep Kumar and Ravi, forecasting exchange rate using Holt's trend-corrected exponential smoothing. We are going to look at the Holt, which which makes it very interesting. There's a paper which is by one, also published in 2022 in the European Journal of Operational Research. They used the exponential smoothing method. They use a sample and they use the Holt, which we are going to look at today. And then you have some applied in inventory management, the Holt as well. So today we are going to look at the Holt and you are going to understand it. Then Shen 2021, double exponential smoothing, which is also the Holt, published in Expert Systems with Applications. Okay. And then even in the Journal of Forecasting, very, very high reputable journal, Forecasting Stock Market Volatility with Holt Winters, which we shall look at today. They use a triple exponential smoothing. And so there are so, for example, look at the last one. Okay, now that gold, one of the students I know is looking at gold. Okay, Holt exponential smoothing, which we are about to do. They used that just 5 years ago to predict gold price changes. So whatever we are doing is very practicable, very practicable. So it will help you if you are ever thinking about doing your PhD or if you are doing your thesis, you can apply this. And I'm teaching it in that way so that you can even apply it right now in your thesis. So let's try it. So that was just a way to guide you. We're going to take a simple model, simple data set to see how to calculate each one of these. We are using our original fast chips data, which is a lending producer of microprocessors. 6 months ago, it launched the sales. Month by month sales are what you can see here. In month one, they made a sale of 17, you might call it 17 million. In month two, they made 25 million. And in month six, they made 28 million. So how do we apply the Holt double exponential smoothing? But before you can understand this whole thing, let's go back to a bit about time series. Time series has some classical decompositions that we know. You may recall that in time series, when we started, we looked at patterns. Patterns. A data can follow some patterns. In the very beginning, we looked at some patterns. Some of the patterns were trends. If I remember putting you in syndicate groups, and then I gave you the pictures of these, and then I told you to detect those that are exhibiting trends. Okay, those trends are like rising, in the long term, upward rising in the long term, or downward falling in the long term. But you can see that the thing is up and down, up and down, up and down, but it's rising in the process, or up and down, up and down, up and down, and it's falling. That is trend. Then we also looked at seasonality. Seasonality means that the thing is happening at regular intervals. It's not going up and down. It's going up and down, but it's not increasing, neither is it decreasing in the process. And then we had cycles and so many. Now, the cycle is sometimes combined with trend. So sometimes the cycle plus the trend will give you trend cycle, but we sometimes simply call it trend. So you will notice that when we talk about a data series, and you take a data series like this, one part of that data series is trend, or one part of the data series we can check its availability is trend. Another part is season, and another part is the irregular noise. These three parts are what we call trend. Okay. We have trend, and then we have season, and then we have the residual or noise. So every time series is usually decomposed into these formats. Like I said, the trend is a long-term movement, the up and down movement. The movement is going up and down and up and down, but it's rising. So it's an upward movement or downward. The seasonality is a repeating trend over a fixed period, whether it's daily, quarterly, or yearly. And then the random noise. That's what the random noise. You can't even see how it looks. It looks like that. So those are the three parts. These are what we call the decompositions or the components of the time series. Sometimes it is actually called trend seasonality lowest. I'll explain that as we go further. Now, there are two decompositions. So, first of all, let's take the data series. What is the data series here? This is the data series, the Y. And this data series can be split, decomposed into three parts: the seasonality, the trend, and then the residual. This, when they are added, this becomes the additive decomposition. But when they are multiplied, this is known as multiplicative decomposition. Whichever one you want to do, you can do it. The interesting thing about the multiplicative decomposition is that you can actually, because you see, if you look at the multiplicative, it's simply a matter of saying that Y is equal to STR. And because it's multiplying, you can take the log. So if you take the log, you will be able to now make it additive. Additive. If you have ever heard about Cobb-Douglas production function, that's how it is. Okay. So this whole decomposition is sometimes called seasonal trend lowers decomposition. STL decomposition. The STL decomposition. Now, the season part is extracted. In other words, if I pull out only the S part, I am able to pull it out using something we call LOS, locally estimated scatter plot smoothing. This is what you use to pull out that. And this decomposition is well known. It is very effective to do it in Python. It's not effective doing it in Excel at all. But because I've promised you that I'm going to focus on Excel, I've tried to decompose it in Excel for you. It just have to be done one by one. But then in Python or R, it does it automatically. Okay. So this decomposition is very important to know. Why do we need to do it? Okay, so the answer is here. First of all, get the difference. In the additive decomposition, so there are three decompositions here. The first one is just additive, where the seasonal type is constant, so you are adding them. But the multiplicative is proportional. The STL approach, it uses the LOESS, locally integrated survey smoothing. Now, the table here will tell you a bit of the differences in all of them. But the key point you want to take note of this is that the STL is more important, and it's really, really good compared to the rest. Why do you decompose? Why don't you just have the time series there? Well, you want to understand the underlying trend over time. You want to know whether something is underlining the thing. You want to detect whether there are some seasonal patterns that are repeated at a fixed interval. You want to know. And you also want to know whether there are some irregular noises. So the decomposition helps you to be able to know the drivers. A typical example is if you tell me that a person is sick, first thing to do is to take blood tests. You want to know what the situation is. You want to know the factors that are causing the person to be that weak and sick. It will come from different sources. So the decomposition is good, but it's not just that. In real life situation, if you want to do forecasting, you need that decomposition. If you want to do anomaly detection, you need that decomposition. If you want to select a particular model, you need that decomposition. So that's why it's a kind of a first stage that, and since we are doing forecasting, that's why we need. Okay, so with that done, let's now officially look at the Holt double exponential smoothing. Now, because this involves a bit of math, I'll slow down. And if you have a question, you can ask me. So take a time series. What do you mean by a time series? This YT is a time series. The YT is here. If this YT is increasing, let's say it's the sales, and this sales is going up and up and up, or the sales is going down and down and down, but at a fixed rate, fixed is going up, 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 but at a fixed rate, then it can be described by a linear trend. Now, when I say a linear trend, you remember the regression you did. Y is equal to, alpha plus beta x plus error term. This is a basic knowledge of linear trend. Because it has some relationship. So what are we saying here? What we will be saying is that the dependent variable, which is a y here, next week when we do regression, you'll understand. The dependent variable is dependent on time. So it means that the dependent variable here, which is sales, is affected by time. As time is increasing, sales will be affected. As time is increasing, sales will be influenced. And so we say that the sales depend on time. But you want to understand something. You see, and it is true. Sometimes if you look at your sales that you have in the shop, and you look at your sales depend on other things, but it also depends on time. So maybe in the beginning of the year, January, there wouldn't probably be much sales. But in February, sales will be increasing. In March, it's increasing because now activities are coming. Valentine is coming. Easter is coming. Ramadan is coming. And so as the time is flying by, the net sales, the total sales is increasing. And so by the end of the year, you will notice that your sales have gone. The question is, by how much does sale or a sale affected by time? The time is the T here. By how much the time affects the sales, that is a beta parameter. That's a beta parameter. So that is one first thing. So what you are seeing, when we talk about a linear trend, this is what we mean by a linear trend. In other words, you have a dependent variable being influenced over time, by time. Okay. Now, I want you to pay attention and look at the values of beta naught and beta 1. If those values are slowly changing, then Professor Holt comes into the picture and then changes the usual exponential smoothing method that we know. Because it has a trend in this one. Now, that one that we did, we didn't incorporate any trend. If you can remember, okay, when we had that, basic exponent, you remember the one that we had the alpha, okay, representing the, what do you call it, the smoothing parameter. And then 1 minus alpha, representing the dampening factor. That was it. Alpha and then 1 minus alpha. There was no trend. So alpha was dependent on its current values. That's the first part. And then the beta was the past forecast. The past forecast. And so that is how we did that. But it didn't incorporate trend. Now, when you don't have the alpha, in this case, the beta naught, and then the beta 1, when neither of them is changing, you cannot use the ordinary least squares. You can. When none of them is changing, you cannot use, when none of them is changing, OLS can be used to forecast the future value if they are changing. If they are changing. Sorry. If they are changing, OLS cannot be used. Okay, if they are changing. But if they are not changing, OLS can be used. If they are not changing, OLS can be used. But if they are changing, OLS cannot be used. So get that. Sometimes it can be slightly confusing. Okay. So now you can combine the beta naught here and then to the beta 1 here. And then the two of them will give you what is known as the mean, the mean of the two. But if you take only the beta 1, you're not talking about the mean. You're talking about how the time is growing. So this becomes the beta 1 becomes the growth rate of time. But this growth rate of time is what we mean by the trend. It tells you how this variable on the left side, the YT, is trending, how it is trending. Now, with that in mind, we can now define the Holt double exponential smoothing. Look at the formula. If you want to forecast a value of sales on the left-hand side here, you need the last value of sales. Multiply that by the same smoothing parameter. Then you need the last forecast. Now, this is how the simple or single exponential smoothing was. Okay, last time we did this part here. Let me just use this one. This part that you are seeing here, that is what we mean by the single exponential smoothing. That's it. That's a single. So this one here is a single exponential smoothing, the SES. Write it down. Write it down. Write it down. Single exponential smoothing. So that was a method that we looked at. Okay. There was no trend. There was no trend. But now, in the double exponential smoothing, there is a trend. And this is that trend. So we have incorporated trend in addition to what we already know. And what we already know is the one in the box. So what Charles C. Holt actually did was to incorporate that trend, because he got to realize that there are some data that incorporates or that has trend behavior. How do you now write the formula? So this is it. The forecast, this is a double exponential smoothing by Holt. The forecast of the sales value is both the level, which is the first part here, plus the trend, which is a T. But you can remember that the trend had a coefficient. Okay? That is, it is telling you by how many times or by how much time is changing. Okay, the extent of the change in the sales due to time. That's what it's telling you there. The extent of the change in this. Now, if you have an exam or something, I'll give all of this to you. Okay. So take this. If this is your T time, okay, and this is your level, and this level, by the way, this level is the whole of this one there. Okay. Then the forecast, which is the left-hand side, is just the level plus the time. Okay, but the time has got an H in front of it. The H is telling you how much time is affecting the forecast. Let's look at the level itself. The level itself can be split. Okay, let's look at how the level is defined. This is the level. Now, remember that, let me just delete this part. This level was known already from the previous. This is a level. What you see is a level. Okay? Now, this level, if you check it carefully, it says that I need, okay, so the level is equal to the sales for this year, for this month. But you have weighted it, as you can see. And then 1 minus that weight. So if weight is 0.3, 1 minus 0.3 is 0.7. And then what you do is that you multiply that whole answer by the level of yesterday or the past, and then add the trend of the past to it. That will give you the level of today. This we knew already. The only thing is this latter part. We knew already from the simple exponential series. The next item is this right part, which is the trend part. So don't forget. Let's look at the trend now. The trend part is also given by this formula. It's very simple. If you understand it, it's very simple. Always note that T minus 1 is previous year. So what this one is saying is that to get the T alone, you must have beta star. I will explain what beta star. Multiplying the level. Now, this is the level you calculated from here. Okay, the LT. That LT you calculated, that is what is here. And then you should also have so you're having the difference in levels. That's it. You're basically having the difference in levels. And then you add the reciprocal, I mean the 1 minus the beta cap that you have, multiplied also by that same level of the previous. What is this whole equation saying? I'll tell you very soon what it's saying. But now, so now once you have calculated the L in this second middle equation, and you have calculated the T, you just bring them and drop them here. And that's it. Now, what is this H? H is simply the number of steps ahead to predict. It's sometimes called a forecasting error. What is that? What that means is that the number of times ahead to forecast. So if you want to start the forecasting at time period 2, how many steps have you moved? You have moved 2 steps ahead. If you want to start forecasting from time period 4, okay, then your H value is 4. So it is a forecast horizon. As for the alpha, we know it's a smoothing parameter. As for the beta, we know it's a smoothing parameter. That's it. The L is a current time estimated. And then the T is also, the L is a current level, and the T is a current trend. Okay, so far I've explained the model. Anybody with a question? Anybody with a question? Yes.
Yes. No, please, the H, I didn't quite get it. If you can help me repeat it.
So you remember that when we're doing the smooth exponential or even the weighted, sometimes we say not available, NA is not available. So we start from the next period, you remember?
Yes, yes.
So the H will tell you which period you are starting from. So if you stop period 1 and then you come to period 2, then your H is 2. But if you stop from period 1 and stop period 2, but then you start forecasting period 3 onwards, your H is what?
3.
Exactly. When we start looking at the examples you get. Okay. Now, just like in the single or the simple exponential smoothing, the level, and now I'm explaining even further, the level, the LT, if you look at the LT mathematically, just look at it. It's telling you that it's a weighted average of these two. So first you have the YT, okay, and then you have the past of the two. So it is a weighted average of observations. Okay, this YT observation. And the 1 step ahead training forecast for time T. Now the 1 step ahead training forecast here is this. So That one step ahead means that you ignore just the first one and start with what? You ignore the first one and start with what? Which period?
Period 2.
Exactly. So that one step ahead forecast is given by this. Okay. It is a training. So in other words, it doesn't necessarily mean that you are ignoring the period 1. It depends on which period you want to look at. So let's say that you want to start from period 3. Then it means that your one step ahead forecast, well, let me put it this way. When you want to start from period 3, it means that you have left period 2 and you are starting from period 3. You want to start from period 5, it means you have left period 4 and want to begin at period 5. So basically, if you check the formula here, it is just the dampening factor. Not this one is a smoothing factor. 1 minus the smoothing is a dampening. It's a dampening factor multiplying the one step ahead focus. Okay. What about the trend? Go back here, the trend. This is a trend. So what is the trend? Watch it carefully. The trend tells you that T, which is a time, because the trend is actually T on the left-hand side. So it means that T is a weighted average. So now that word weighted average means you have gone to the right-hand side. So why are we saying weighted? Who can tell me? If you look at this equation, why are we saying weighted average? What makes it weighted? What makes it weighted? Which letter makes it weighted? Which letter is the
I
weight?
think the beta.
Is the beta side, yes, it is. It's a beta. So that's what makes it weighted. If you don't know, you just write it down. So is the weighted average of the estimated trend at time t based on the level at time t and the level at time t plus 1, as well as based on the trend at t minus 1. So the t minus 1 means it's the previous. So we are calculating the t today, but we also want to rely the t today, the trend today, but we also want to rely on the trend yesterday. So here you will notice that we are relying on the trend yesterday. That is how you do the trending. Once you have done the level and you have done the trend, what do you do? What do you do? Once you've done the level and you've gotten the value and you've done the trend, what do you do? You add. You add. Okay. That's what the 8-step ahead forecast have explained it. So we are going to go to our case study and then remember what these we are doing. Okay. So the first thing we are going to do is to remember our smoothing parameter. What value did we use? 0.2. Which means that our dampening parameter is what? 0.3. That's what you have. Okay. But now we have introduced another value. Okay. And that is, oh, sorry. The um the 0.2 is the smoothing parameter, okay, for the level, which we always know. We always know that from here. Okay. So this is the smoothing parameter here, the level. But of course, the smoothing parameter will have its 1 minus the smoothing parameter, which is the dampening. Okay. But the trend will also have its beta, and that's the beta value. So here, the beta value has been given to you. Okay. I've given you a beta value here. Just go to there. So here, you'll notice that I've given you this beta value to be 0.3. That is a trend, the smoothing part for the trend. And then the 0.2 is a smoothing part for the level. The smoothing for the level. When we say the level, we've already explained many times, the level is what is actually there. what is actually there? What is actually the value? And then the trend is that part of the data that is trending by what value. So this is the sales. Can you calculate the L and then the T? This is an exam question, by the way. Can you calculate the L and can you calculate the T? Let's do it together. So the first thing is that we are going to calculate the L here in this column. The L, because the period starts from 1, the L is going to start from 1. But the L1 is equal to Y1. Why? And the Y1 is what? The 17. Y1 is the sales in period or month 1. So that is going to be 17. Why? The reason is because we don't have any, you see, when you look at the equation up here, okay, like we should have some things here. We should have some things here. We should have some things, but we don't have some things. Why don't we have? Because we've not done any forecast to have a previous. We've not done any forecast to have a previous trend or a previous level. We don't have. And because we don't have, we cannot even have anything for the previous. And so our current level is simply going to be the sales because we have nothing. We have no data. And that is how come the L1 is equal to the Y1, which is equal to 17. Okay, so now at least we have something. So when we go to the next period, we'll be able to refer to this one. So how do you find the trend? Remember that the trend parameter is what? You can tell me. The trend parameter, the trend smoothing.
0.3.
0.3. We're going to use that 0.3 to calculate this one. How do you do that? Well, look at it carefully. Okay. Now, the trend is given by the second period minus the first period. Now, why? Why? Once again, we would have used this formula here. But again, we are in year 1, period 1. Or in this case, month 1. And because we don't have any prior, because watch it carefully, there are some prior elements you need here. The LT minus 1 is prior. The T into bracket T minus 1 is also prior information. We had nothing, no prior information. And that is it. So if no prior information, then why did you get the 8? Well, anytime you don't have prior information and you're calculating the trend, what you need is that you need to have the current value and that of the future actual value. That will always give you the first trend. Any question, anything that is not clear? Okay. So now we know L1 and L2. What can we do? We can now use this L1 and L2 to do our forecast. But this forecast will not be for the first period. It will be for the second period. Now, why? Because remember, we are doing an 1 step ahead forecast. One step ahead forecast means that we ignore the period 1 and start from period 2. So that's why you can see that I've called this one F2. How do you solve it? Just take the level you have, L1, and just take the trend you have. Okay, and then you add them. You add them. So whatever you would have calculated for level on the side, just write it there. Okay, you have calculated a certain point here for the level, and you calculated a certain point here for the time. Okay, so now you add the two of them, but that will not give you the value. Okay, so you have 17 here for the level, you have 8 at the time. So what you now do is to add the 2 to get to the forecast. And whichever forecast you want to do, but let's call it FT. Now that will give you 25. And that is the forecast for the second period here. It's forecast for month 2. If I tell you to tell me the forecast for month 3, you should be able to tell me. How do you find the forecast for month 3? All you got to do is to find the level. Now, how do you find the level? Now that you have all the information, you're going to substitute the value. So what to be the value? I want someone to work it, and then I want you to tell me what is going to be your value. Don't copy the answer anywhere, because I'll ask you how you got it. Who is not clear? Who has a question? Who is ready with his answer? If you're ready with your answer, I'll just let you, I'll give you marks. I'll just let you unmute yourself and then tell me. Anybody?
So we are solving for F3, right?
Yes, we are solving for F3. And if you have a question at this stage, just let me know. We are solving for F3. Remember, at this stage, we know the value of level for the period 1. What is the value? Level for period 1.
17.
And then trend for period 1.
8.
8. And of course, forecast 1 was not to be done. So that will obviously be NA. And so we need to use those information to do forecast for period 2. And we found forecast for period 2 to be what?
25.
25. We've done that. Now you are going to use the information here to get. Now, if you were to write the formula, okay, what do you think the formula will be? What do you think the formula is going to be? Okay, remember the formula is the same thing that is up there. So here you are going to have alpha replacing this. Remember, we are trying to find the L. So what is the value of alpha? 2.
1.2.
What is the value of YT in the period 2 we are dealing with? What is it? What's the
25.
value of
25.
25? Good. And what is the value of 1 minus alpha?
0.8.
0.
8.
I can hear you.
0.8.
Good. 0.8. And what is the value of LT minus 1? That is the level previously. What is the value?
17.
Sorry?
17.
The level. Yes, that is 17. Okay. And then the, what do you call it? No. We are not calculating the level for the previous. Oh, yeah. 17. And then the next one is the trend for the previous. What is the trend for the previous? That will be
8.
That will be 8. Very good. So when you add all, you're going to get your value for L2. What will be your L2? I mean, the worst thing you can do is when you have the slides with you and then you are looking at it and mentioning the answers. But I know that you are all working along. So what will be the value of L2 if you substitute it? So you're going to have 0.2 here, okay, multiplying the YT, which in this case is going to be 25, then plus 0.8, which is a 1 minus the alpha, into bracket 17, which is the previous level, plus 8, which is the previous time. Remember, here is the previous trend, So when you do that, and then you simplify, what value do you get? Let me ask somebody here. Let me be sure that Sophia, are you here? Sophia,
I'm here.
what value have you gotten?
Dr. I was a bit distracted, so I'm not following you.
So you are now following, right?
Yes, I'm not trying to first.
Good. So I'll come back to you again. So follow.
Yeah.
Selena Adams, what did you get?
Please, I got 25.
You got what?
25.
You got 25. Let me ask another person. Anyway, that's a correct answer. Let's move on. Okay. Now, we are now ready to find the T2. Okay. The T2. Remember, you use the T2, the L2 to find the F3. That's how it works. You're going to use the T2, the F2 to find the F3. So we just got to this value. So let me just wipe off this so that you see the original values we had. Okay. So this was the original values we had from the previous. And now we just found this value, 25 L2. Just as we did for the previous one, we're going to find T2. Now T2 means that you should find the beta star. What is the value of the beta star?
0.3.
Good.
0.
And now
Yeah.
it says you should get the LT. Okay, that is the level that you just found. Because remember, since we are in period 2, we are finding the LT. So what is the LT? L2 is this very one. The green one we just found. The L2. That is 25. What is the
25.
LT minus 1? Or the previous one. So this one, it will be L1. What is the L1?
17.
17. Then it says plus, look at it. It says plus 1 minus the beta. What is the 1 minus the beta?
0.7.
0.7. Then it says after that multiplied the TT minus 1. The TT minus 1, since we are in period 2, it is talking about trend 1, the T1. What was the T1?
8.
8. So you're going to now simplify, multiply, and add all of them. What is the value of T2? What is the value of T2? Michael, are you with me?
Prof, I'm with you, but I'm pointing my calculator, please. I'm
All
with
right.
you.
Selena, are you with me?
Yes, please, but I'm calculating.
Okay. Kwajo Boache.
Say I'm here. I'm a bit lost.
But you didn't ask. You didn't say that you're a bit lost until I called you.
I
You
thought
didn't
I
know
was
you
going
were
to
lost until I called you.
No, I thought I was going to figure it out by just studying it.
How can you be figuring it out when I'm here? That you can take advantage of my presence.
I understand.
So think about the right question you're going to ask. Yes, Selena.
Please, I got 8 again for
Got
the
8, and that is correct. So now add it and then find F3, the forecast for period 3. The forecast for period 3. Remember that F3 will come in the next lane. Okay. So we have gotten this value. We have gotten the value here. Okay. We got this T1, the T2 now to be 8. So it means that whatever we have here, we now know this value. We now know the value here to be 25. Okay. We now know the value here to be 8. Oh, remember the forecast here was 25. Oh, don't forget. The forecast here was 25. we are now looking to forecast this one here. We are looking to forecast period 3. So to forecast period 3, you just have to do an addition of this 25 plus 8. What does that give you?
33.
So you now have this value here to be 33. So you've been able to use the information from period 2 to forecast for period 3. Therefore, we can conclude that our period 3 forecast is 33. Now, can you use that same information to forecast for period 4? That means you need to calculate the level for period 3. In other words, you should come back here and come and calculate the level for period 3, the trend for period 3, and use it to forecast for period 4. Can you do that? If you can do that, we'll move on. If you cannot do that, we'll work it out together. Can you do that? Let me ask somebody. Francisca, could you have done that?
Hello, Doc.
Could you
Yes, please.
have done? Okay, Bishop.
Looking at the previous one. Okay.
Okay, Bishop, could you have done that?
Yes, please.
Akofa, could you have done that?
Yes, Doc.
Good. So I want to assume that you could all have done that. So we're just going to move on so that we don't delay much.
Doc,
Yes.
I don't know if it's a silly question, but you see so for F3, we are doing L2. I thought we'll do L2 plus T2. Why is it called B2?
Which one?
So
Oh, that's another name that Hinderman normally gives. In fact,
okay.
always whenever you see, I mean, I should have changed it because the L stands for this L stands for, and then the B stands for the T. It's actually the trend. It's a typo. It should be both.
All right.
All right. So if you do all of that, you're going to get that value. Okay. The L3 is here. Okay. So if you find the L3, you're going to get 31.2. That's the one at the top here. Then you find the LT3, you're going to get 7.46. That is here. And now you can add the two together, and that will give you the forecast for the period 4. Okay. So we have been able to use the level and another level, and the level for period 3 and the trend for period 3 to get a forecast for period 4. This is a forecast. This is how you do it. Any question on this? You would get this in your exams. You will get something like this in your exam where you have to calculate. So it's important that you understand what we are doing. Okay, fantastic. So we are now ready. Once you have been able to fill this portion, all of this, watch it. Okay, let me just remind you of something. So remember this data we have been using it. Okay, so this will give you the T4, and then you can use that to predict for T5. So you can see that now we've been able to use it to predict the forecast for every period. Of course, except for period 1, which we didn't have previous information, and so we couldn't do the forecast. Now, whenever you finish forecasting like this, do you remember the next thing to do? The next thing to do is that based on the forecast values and the actual values, you find your what? Who can remind us?
The errors.
Exactly. So you create a column to find the errors. And the errors is basically taking the forecast values and then finding the difference between the forecast values and the actual value. That is what we are going to do. Okay. Now, there are several of these forecasts accuracy methods. Okay. But the common ones are always used. But I've given you in the other Excel, I've given you how to do all of that. Now, let me just take you a little bit, okay, here to show you how to calculate each of this. So look at this. I've brought all the results here. So we have all the results. So we can calculate our errors, okay? We can calculate the errors. Now here, when I show you boom like this, you'll not even understand how I got the errors, okay? So let me just remind you of the first error, sorry. To get the error, it is a forecast value minus the actual value, isn't it? The forecast value minus the actual value, that's the error. Or is the other way around? Forecast value minus the actual value, actually. No, it's the actual value minus the forecast value. Then you take the absolute value, just so you know. So it is, the error is the actual value minus the forecast value. So the first one, the actual minus the forecast is 17 minus nothing. Okay, so that one, we leave that. Okay, we don't need to even bother ourselves with the first one. So go to the period 2. The period 2 is 25, which is the sales value, okay, minus the forecast. The forecast is also 25. So that gives you what? 0. And then the next one is 24 minus the 33. You're going to get a negative value. Okay, and then positive, negative, whichever it is, whatever you get, then you now take the absolute value of this forecast so that all the negatives become positive. In fact, that is what I've just done here. So what I just did is I rather focus on the absolute value. So for example, the second one was 24 minus 33. 24 minus 33 is negative 9. The absolute value of that is 9. So that's how come you get 9. If you take a calculator and you check the next one, which is 26 minus 38.66, you're going to get 12.66. And then when you take the absolute value, it's going to get negative 12.6. And that will give you 12.66. And then the rest follow beautifully like that. I hope you get that part. Can I move to the square?
Yes, bro.
Good. Now, the square is just taking the value of the errors you've gotten here. Okay. Whether it's the positive values or the negative value, whichever one it is. You square the value, and then that will give you square. So you can see that 0 square will be 1. 9 square will be 81. Because it's 9 times 9. 12.6 times 12.6. Okay. This value square will give you 160.26. And then the rest will follow like that and like that. Good. Once you found that, you just have to find this and put them down first. Because once you get these ones, finding the forecast accuracies are easy. So finding whether the forecasting is accurate or not. Using this Holt double exponential smoothing is easy. So now you take the next one. The next thing to find is this value. Take the error and divide the error by the actual. So as an example, take this error here. Okay, you divide this error by the actual value. 0 divided by 25 is going to be 0. So nothing there. Let's take the next one. The next one is 9. 9 divided by 24. If you take your calculator, check it. What is 9 divided by 24? Quickly. Punchy B. Punchy B. What do you get? I need a smart person to give me an answer.
0.375.
Exactly. That is the same value here. I just want you to familiarize yourself with these things. Because once things have been done for you, you don't take care, you will not even point. Your brain tells you that you know when you don't. So that is what you got to follow to find each absolute value of the error divided by the actual. That will give you each one of these. The next thing is to multiply whatever answer you have here by 100%. That's it. Whatever you have, multiply by 100%, that will give you each one of these values, which is what you have here. You attach the percentage to it. Then the last column is called the S mapping. Okay, we've talked about this in the previous lecture, the S mapping. Now, the S mapping, there's a formula for calculating it. And the formula is what I gave earlier. Okay, you may have forgotten, but this is the formula. It's a bit of a complex formula, but if you take your time, you see, say there's nothing big deal about it. Okay, it's yi minus 0. So it is the error here. The top part here is the absolute value of the error. Then here you take the absolute value of the y, then the absolute value of the y cap. Each one of them, you take these two, sum them, and divide by 2. Meanwhile, the error is up there. The absolute value of the error is up there waiting for them. Then you take the sum of all the numbers you have, and then you multiply, divide that by the sample size and multiply by 100. That will give you each one. If you check the previous one, you see that. In fact, the one I just sent you, you will see that. So now you have the S mapping. We can now calculate each of the forecast accuracies. What was the first one? Well, the first forecast accuracy is the mean absolute error, this one. Okay, now that we have all these things, it's just a matter of adding. So in an exam, I'm not going to give you all of this to calculate. I'm just going to give you some of them to calculate. Okay, I'll give you the sum, but I will let you calculate others. I'll give you some, but I'll let you calculate. For example, here I'll give you the S mapping result because it's complex. It might take your time. But then here I'll leave some blank. So for example, say I'll leave this one blank, and then I'll tell you that you should calculate this. But I will not give you this. So I'm expecting you to be able to calculate this by yourself and then multiply by 100 to get the 48.692. Okay. Once you are done with this, I would ask for the forecast accuracies down here. You will have to calculate all of them. How do you get the mean absolute error? It's simple. 0 plus, you just take these errors, okay, this one, and just add all of them, divide by 5. Now, why 5? Why not 6? Because we have 6 sales. Why 5? Why 5? Let me see someone who hasn't spoken. Ethel, are you here, Ethel?
I'm here. I've spoken. Oh, okay.
Why 5?
But
You
why
tell us.
5?
Say,
Because
should I let me try?
No,
okay.
Ethel is talking. You can't stop her. She's talking.
Yeah, so 5 because the we forecasted for 5 how do you call periods, and
Listen,
so that's what you use in the calculation.
good, good. So that's it. So it's just a matter of taking the in fact, when you have these numbers, it's a matter of taking the average. So in the Excel gives you the result. Okay. Just taking the average. So you take all of these sum, divide by that, and that gives you the mean squared error. Okay, that one is also the squared ones. So again, the squared ones you take the average. But then you go to the next one. The root mean square. It's just a square root of the one you did before. But then you go to the mapping. Remember, the mapping is the one with the percentages. So that one too, you just do that. Take each one of them, divide by 5, but you multiply it by 100% so that you get it in percentage. But then you go to S mapping. S mapping is the last column one. So that one too, you take the mean of all of them, but you get it. And on the basis of this, you can tell which one is probably going to be the best. That's it. Now, let me just clean this. So this is what you can do for Holt, okay, double exponential smoothing. Now, there's a last one, which is called the Massey. The Massey is very easy. All you need to do is know the naive forecast, the value of the naive forecast. Who can remember from last time the value of the naive forecast. Do you remember the value? It is 3 point something. Let me see whether somebody has a very sharp memory. What was the value of the naive forecast? The mine for the naive forecast. The value. It was 3.4. It was 3.4. And what is the MAE here? What is the value of the minimum absolute error here? For this Holt.
10.536363.
10.54. So you now take the 10.54 and divide it, okay, by the 3.4. That's what I've just done here. And that will give you 3.09. That is the massive mean absolute scaled error. So that's how you calculate all of these errors. How many errors have we calculated here so far? That's more than even 5. You have 3, and then you have the next 3, making it 6. Finish. So here you can rank them from the lowest, which is the best one, to the highest, which is the worst one. That is how you do it. Let's go to the next one, the last one for today. And that is the Holt winter. Holt winters is no longer double, but it's triple exponential smoothing. Triple exponential smoothing. Now, all it does is that it keeps everything from the Holt approach. If you look at it, the year was just 1957 and then 1960, just 3 years after Holt. And it is called Holt winter because it has included season. So remember, in the original, you have a data, you have the data is split into level, the error, the trend, and this time the season. That's why it's sometimes called Holt triple. Triple here means because you have level, you have trend, you have season. It is a forecasting of the equations with 3 smoothing equations. What are the 3 smoothing equations? The first one is a level where you have a smoothing parameter. Remember that smoothing parameter was the original one. We used to call it smoothing parameter, which has its other version of the 1 minus the alpha, which is the dampening. The first one is going to be the level. 1 is going to be for the trend. And then 1 is going to be for seasonality. Look, there are certain sales in life, they are backed by season. You cannot stop the fact that that shop is going to go make more sales in Valentine. And that shop is going to go make more sales in Ramadan or Easter. That shop is going to make more sales in Christmas. So there are some seasons. So when sales are high, you don't attribute it to management is doing well. Management is doing well. Management is doing well. No. You know that seasonality is causing the spike. So you got to incorporate seasonality in the data set, in the model. And that is what Holt winters that. There are papers that, as I speak, are being written right now. Now, do you remember that the level has a smoothing parameter called alpha? The trend has a smoothing parameter called what? Beta. There's a reason why we use beta star instead of beta, because later on, Hindeman actually explained why we have to use beta star. But since we may not get a time to explain, you might see beta, it doesn't matter. And now we've incorporated another final variable. This one on the far right. Do you know what symbol this is? Who can tell us this last symbol here? Yes, Sammy?
Gamma.
Gamma. I mean, it sounds alpha, beta, gamma. Okay. Alpha, beta, gamma. So they move together. So this is a gamma variable, and it is standing for which one? Which component?
Seasonality.
Seasonality. So seasonality too has to be weighted. trend has to be weighted, level has to be weighted, and then combine all of them. You have the hot winter. Now, watch this. One thing about a hot winter is that I told you this is the most difficult, but it's doable. One thing about a hot winter is that you need to have a period of the seasonality. Yes, Michael.
Yeah, Prof, I wanted to know whether the seasonality that's the can also be described as period.
No, you cannot describe the seasonality as the period.
Okay.
Yeah.
Okay, thank you.
It's not the time, because the moment you say it's a period, you are talking about time here. But it's not
Okay.
but it is the action that is happening during that particular time.
Okay. Okay, Doc. Thank you. Thank you.
Now, what is P? P is also M. What is P or M? Now, the period in which the season happens. So let's say that in a year, there are two particular seasons that you are expecting to change sales. Then in this case, P is equal to what? P is equal to what? There are
Doc,
two,
kindly come again.
in a year, there are two particular seasons that will change sales dramatically. So in this case, P will be equal to what?
Two periods. So,
Now, imagine that in a year, you expect that sales is going to be affected by Valentine, it's going to be affected by Easter, it's going to be affected by Christmas. So in this case, P is what?
3.
Exactly. So P is the number of seasons within the year. Okay. So if you have P being equal to 4, it means that you are kind of having quarterly data that is split into seasons. You can also have monthly data. So the spikes there happens monthly. But there are some, the spikes will rather be happening quarterly, because that's when the seasons happen. This period will be given to you. You must always know the number of period or the period of the seasonality before you start computing the hot winters. Now, there are two methods that can be used to calculate the hot winter seasonality. I will not do the two, I'll do one. The first one is the easier one. Well, both of them are easy, actually. Yes. One is additive approach. Which one do you think is the next one?
Multiplication.
Multiplicative. So the additive is used when the season is constant in magnitude. Take note. So let's say that the thing happens the same, like it happens every 4 years, every 4 months, every 4 months, or it happens every 2 months, constant, magnitude. But then the multiplicative is used when the season rises or falls with a trend. Like, it's not that it can rise, it can fall, but it is intertwined with some trend. Trend here means that it is the whole thing, when you look at it together, is going up, or the whole thing, when you look at it together, is going down. But even though it's going up and it's going down in the long term, in the short term, there are spikes in between. There are spikes in between. So that is the multiplicative. Well, I'm going to give you the additive formula, and then I'll give you the multiplicative formula. But like I said, we'll only apply the additive formula. Well, it's very simple. If you look at it, this is a forecast, just like the previous one. What do you think I've added to this formula different from the Holt double exponential smoothing? What have I added to this forecast formula? The forecast, of course, is the left-hand side. Okay. The left-hand side is not changing, but what is on the right-hand side that has been added here?
no, the season,
The
the
seasonality.
The seasonality, the last part, this one.
Yeah.
That's the thing that has been added here. Forget about all of these mumbo jumbos that are subscripted here. Okay? The key is S, which has been added. Yeah. I know. Sometimes when you see some of these mambo jumbos, you feel like. Then, if you look at the level, only something small has been added. Can you detect it? What has been added in that equation? Nothing has changed except one thing. Who can spot it?
ST minus P.
Exactly, the ST minus P. At first, it was what? At first, what was in the bracket? What was presumably in the bracket?
The previous level.
The YT. Exactly, the YT. Not the previous level, but the previous, the actual,
Sales.
sales.
The previous the sales.
Yeah, the actual sales. So at first it was just YT, and now we have subtracted season from the YT. Every other thing remains the same. Okay, now let's look at the next one. The next one, of course, is going to be the trend. So let's look at what has changed in the trend too. What do you sense has changed in the trend? Be careful. What has changed?
Nothing. Oh,
Nothing. 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 Because there's nothing, the season is not going to be affecting the trend. There's no connection there. Okay. Right. So now let's look at the final one, which is the season. The season will not be, changing. The season will not be affected by the trend, but the trend will affect the season. Take note. So as for the last one, is the last one that I've given you. It wasn't there before. It wasn't there before. So that is the key. But if you look at it carefully, it is being influenced by several things there. Do you realize that? For example, you have the actual sales, current actual sales impacting the season. You have the level, the previous level. You have the previous trend. Okay. And then you have even the season itself. The season, the P here means the season relative to the seasonality period. No? Okay. Maybe it can be the past. Okay, season, but we don't know which particular past. It can be the double past or the triple past. Okay, whichever one it is, it's affecting the current season. So that is the formula for the season. Okay. Now, let's get an interpretation of each one of them. We know some of them already. The level. The level is the same thing as before, but it's now the weighted average between the seasonally adjusted observation. So you see, at first it was just the weighted average of the observation. But this time is the seasonally adjusted observation because the observation has now been adjusted. You've taken an adjustment parameter of the season plus the non-seasonal forecast. This is a non-seasonal forecast. Okay. So if you look at this forecast here, okay, this past information, there's no season attached to it. And that is why we call it non-seasonal. So he's just picking this first one and looking at the weight. The reason why he's calling weighted, the reason why he's calling it weighted is because you have alpha here and you have 1 minus alpha here, and they are the weights. And that is what is leading to this word weighted. Okay. The next one, trend. The trend hasn't changed. It's the same thing. We said it before, so we don't want to explain the trend. But now you can see that in the season, which is the next one, there is a gamma. And the gamma ranges between 0 and 1, just like the alpha ranges between 0 and 1 inclusive, just like the beta ranges between 0 and 1 inclusive. Okay. Now look at the seasonal equation, the last one. If you look at the bottom one, the last one, it is telling you that is a weighted, where in this case, the weight is the lambda and then the 1 minus the lambda here. Is a weighted average. The moment you add them, it's like an average because you've weighted them. So it's a weighted average between two things. Okay. One is the current seasonal index. Okay. The current seasonal index, this. And then the seasonal index of the same season last year. This one. Okay. The same seasons last year. In other words, P time periods ago. P time periods ago. So it depends on what the P is. But is the last year. Last year, where within that last year has been split into seasons. So okay, that's what we say. So you have two kind of seasonal elements. What is the first one? The current seasonal index and the previous or last year's seasonal index. That's it. The current seasonal index. Now, what does that remind you? If you can remember, it can remind you of the simple exponential smoothing. In fact, I wish you had a formula for the simple exponential smoothing. The simple exponential smoothing, if you could remember, it had to depend on if you want the forecast for y, okay, which was t plus 1. If you wanted to forecast that, you needed the current information, the yt, and then you needed another one, which is known as previous forecast, f t minus 1. Okay. And the current is given by alpha, is multiplied by alpha, whereas this one is multiplied by 1 minus alpha, if you can remember. Simple exponential smoothing. Simple exponential. That's how it was. So this one is giving us a similar idea like that. Anyway, take your time and try to understand at a later time. Now, we have this information. Oh, that was additive. This is a multiplicative. The only difference between the additive and the multiplicative is that the additive does minuses. So check there. YT minus the season. Okay. The seasonally adjusted observation. YT minus STP. Minus. But then when you go to the multiplicative, it's not minus, it's divided. When you come to the last one, the season, watch it. It was YT minus LT minus 1. Minus TT minus 1. Okay. But that is minus. But when it comes to the multiplicative, it's divided by. So that was the only difference. But that is the only difference mathematically. But what does it mean? Well, here's the thing. If you take the multiplicative is very good when you have a very large data set. Okay. It helps, especially with big data. Okay, so let's go to our small sample. We are going to use our small sample and calculate this Holt winter. But there's a problem. Holt winter will normally not be good for our small example. Please pay attention to know why. The reason why it will not be good is because the data set is small. Even in additive case, forget about the multiplicative case. Even in additive is too tiny. Why? This is why. Because we need to find seasonality. Now, before you can find seasonality, you need more period. Because it is in between periods that you can identify seasons. So you need at least 2 full seasonal cycles to be able to say that there is seasonality. And normally for that to happen, there must be 8 plus data points for quarterly seasonality. 8 plus. So within one quarter, there must be more than 8 items within the first quarter. So if you take the first quarter, that's it. Then the second quarter should have more data, at least 8. Then the third quarter. So if we are to go by the minimum of 8 per within the year, we must have 8 plus 8 plus 8 plus 8, 32. So I did it later, but I have not shown you. I tried to see whether there is any seasonal pattern. There was no seasonal pattern in this 6-month information that I've just given. So it means that a minor work. So whatever I'm going to show you is just for demonstration purposes. Okay. So let's go back to our data set. So this is our data set. We are going to use the case study here to compute the Holt weighter. Okay. We have been given the level, the parameter, the smoothing parameter for the level as 0.2, the smoothing parameter for the trend as 0.3. It's not changed. We have now brought in the smoothing parameter for the gamma as 0.1. That is for the season. And then we have the seasonal, what do you call it? The seasonality period to be 3. Okay. We just have seasonality period to be 3. So how do we start our computation? Well, the first thing to do is to have our formula there for each one of them. These are our formula. Remember, these are additive that we are calculating. Nothing has changed. Everything that you are seeing here is not Hebrew. It's not Hebrew at all because you've seen it before. Anna, Francesca, is it Hebrew? What I'm showing now?
No, dog.
No, we know where we are coming from, isn't it?
Yes, please.
No, we haven't changed. I want you to not panic a lot when you see some of these things. That's why I've even made this one color blue so that you don't panic. Okay. Anyway, so we know all these manya things. Now, first thing to do, in fact, the last thing to do is to calculate the forecast. So that's usually the last thing. The first thing to do. Okay, let me ask you, which one do you think would have been the first thing to calculate? It's only a guess, don't worry.
The level.
Exactly. You are thinking, my brother. You're really, really thinking. Okay, so we are doing Holt Winters additive. What it's going to do is that it's going to update the level. We had the level before, but it's going to update it. It will update the trend value. It will update all of them. And then we introduce a seasonal component. So first, ideally, we should find the level. But there's something interesting here. That is why I want to find the trend first. And I'll tell you why. Now, if you look at the trend there, it depends on the level. And if you look at that level, it depends on the trend. This here. The trend depends on the past level and the current level. The level depends on just the past trend. I want to repeat that. The trend, and let me show you here so that you can understand what the trend here. Let me use a different color. The trend here depends on the past level, sorry, the current level and the past level. So two things of the level is dependent on. But if you look at the level is only depending on just the past trend. That's it. Not even the current trend. Please, are you with me?
Yes, Doc.
Yes.
That is why we find the trend first. Okay. So now, how do you find the trend? Before you can find the trend, you have to remember the seasonal period that were given to you. In the question, how many seasonal periods were given? No. Let's go back to the question. How many seasonal periods were given? Three.
Three, sir.
So we have 3 seasonal periods. Okay. So that means that we have to find first of all, we have to split the periods into 3. That's what it means. Sorry, we have to take 3 different periods. And since the periods are 6, okay, and we need the first 3 periods, and the next 3 periods, and the next 3 periods, and the next 3 periods, okay, how many seasonal periods are we going to have? How many batches of seasonal periods are we going to have?
2.
2. Okay, we're going to have batches of 2 different seasonal periods. Now, once you've gotten that, then you find the average of the seasonal period for the first one. So if you take the first 1, 2, 3, it is 17, 25, and 24. 17, 25, 24 for the sales. Now you will take the difference between the last one and the first one. Okay, the difference between the last one and the first one is going to be 24 minus 17. And you find the average of that, and that will give you 3.5. Now, this is going to be T1, or the trend for the first period. But I have not said it is F1 because we are not going to forecast. Okay. The next one. What this means is that the trend is 3.5 times. So this one, if I were to create a column for the trend, that trend is 3.5 units per month on average. It's positive. Okay. So that trend is 3.5 positive units per month on average for the first 3 months. For the first 3 months, because you are finding the difference between the sales 3 and the sales 1. Now, on the basis of this, we can now, so when you find the T1 is going to be 3.5 to represent the first 3 periods, or what you might call the seasonal period. It is period, but they come together to make up the seasonal period. Okay. Then you find the average. So that is for the T1. That is for the trend one. Trend one, not every other thing, just for the trend one. Then you go to the trend, the level. Because I told you the reason why I'm starting with the trend. You go to the level. How do you find the level? You don't need to use this formula. Remember, when you're dealing with period 1, you don't deal with the formula, because if you can remember the Holt 1, we were even using just the previous values to represent, forgetting about all of this. Because you don't have anything from previous. You don't have. To get a level, this is the standard way you go about it. To get a level, you take the average for the first cycle, the first 3 months. And the average of the first 3 months, you see, to get the season, to get a trend, you take the difference between the first and the third, depending on the kind of seasonal period that you were given. If our seasonal period was starting from 6, we would have found the difference between the 6th period and the first period, and that would have given us our T1. If the period was 4, our T1 would be the difference between the 4th period, the sales of the 4th period, and the sales of the first period. Would have taken the average of that, and that would represent our T1. Okay. For the level, you take the average of all of them. So if it was 6, okay, if the first cycle was 6, you'd have taken the average of all the 6. In this case, the first cycle was 3. So our level will be the average of the first 3. And in this case, it's 22. And that make up the level. So that is how you get the L1 as well as the T1. You don't get the F1 because we are not going to calculate the forecast for that. Not at all. However, let's move on to the next. However, you can find the seasonal indices for each month sales. Now that you have the information here, what do I mean by seasonal indices? Now the seasonal indices, because we have found for the T1, we have found for the L1, so we need to find for the S1. Okay, how do you get for the S1? Well, you can get S1, S2, S3 at the same time. Why? Because they are estimated by comparing each month's sales to the average you've already found. The average of the average that you found, which was 22. You find the 22 for the seasonal cycle. Remember, the 22 is representing the seasonal cycle. The seasonal cycle. In case you've forgotten, let me go back here. Look at this. This 22 is for Y1, Y2, Y3. That's the seasonal cycle. That's the first seasonal cycle. Okay. So what you're going to do is that after you've gotten the first seasonal cycle, now let's take for each season. The first seasonal cycle is a cycle, but let's take for each season. How do you get for each season? Once you know that the first seasonal cycle is 22, in this case, you're going to find the first season to be the actual Y minus that 22. Okay, the S2 is also going to be the actual Y2 minus the 22. The X3 is going to be the actual Y3 minus the 22. So let's do that. So you take the S1 is going to be the actual Y1, okay, minus the 22, which is the L1. The second one is going to be the actual Y2 minus the 22. The third one is going to be the actual Y3, which is 24 minus 22. So you're going to get negative 5 for the month 1, negative 3 for the month 2, positive 3 for the month 2, and then 2 for the month 3. Now, why do you think this value is negative? It is negative, which implies that, and this is month 1. So it tells you that the sales for month 1 was 17. Okay, so it means that the sales for month 1 are 5 units below the average. The average is 22, which means that the seasonal effect of month 1 is weaker than the average. So you see, when you take Christmas, for example, Christmas can have a ripple effect between January and February. Do you know that? Christmas. Whatever is happening in Christmas period in December, it will, even though the Christmas itself is on December 25th, there could be activities buzzing already. Sometimes even starting all the way as early as November. And then it will continue in December and it will continue in January before Valentine pops in. So whatever you are finding for that particular period, that cycle. That cycle is going to be November, December, January, February, something like that. And that is what. But then you will see that maybe sales might be higher in December than in the November, or sales might be higher in the December than in January, or something like that. So that is what this particular one is for this example. Once you have found this, you can now use all of this for the forecasting. But you cannot forecast for period 1. We know that already. You cannot forecast for period 2. You cannot forecast for period 3. Why? Let's continue. So this is our sales. We are going to now find our forecast. We already know the value for the level. It's 22. We just showed that. It's L1. That's why it is in period 1. We know the value for the trend. It's 3.5. How did we get a 3.5? Remember, we took the difference between in our first cycle, between the latest and the earliest. Okay. Well, what about the season? We just found the season for the period 1 to be -5. The season for period 2, we already have it. The season for period 3, we already have it. So it's -5, 3, and then 2. Okay. However, we cannot find a forecast for period 1. We know that. And sometimes, and this is for this particular example, because, and you see, I think I've already explained what is L1. Okay? I've already explained. That is just the average of the first season. So this one. And then S1, I've already explained. T1, I've already explained all of that. Now, the question is that we are not going to be able to calculate the hot winter. Now, the hot started from period 2, if you can remember the previous one. We left the first row empty. We are still going to leave the first row empty for period for the hot winter. For the hot winter, let me just take here. Hot winter, we are not going to be able to find the forecast for this. We are not going to be able to find the forecast for that. We are not going to be able to find the forecast for that. I'm sure by now you should know why we cannot find the forecast for this. But we can find the forecast starting from period 4 here. So I have a question. Why is it that in this hot winter's additive, we are starting with 4? I mean, for period 4. Why are we starting at T equals 4?
So I think it has got something to do with the seasonality components that has been introduced in the hot weather calculation.
You have an idea. Explain further. I'm going to say with T.
So
Repeat it here.
So I am thinking that for the first season, because we are dealing with seasons now, for the first season, there is no previous forecast to be used to forecast for the first season,
The first seasonal cycle.
for the first seasonal cycle.
Mhm.
So we can only calculate for the second seasonal cycle.
Mhm.
Hello, sir.
Yeah, I'm listening. Are you finished?
Yeah, I'm done.
Okay. Okay. So here's the reason. You've tried, at least you've said something. The minimum data needed is 4 periods. Now, why? Because you always need what we call the seasonal period, which in our case is 3. You need that plus an additional period, making 4 periods. So whatever the seasonal period is, if the seasonal period is fixed, then you start from period 7. That's what it means. If the seasonal period is 4, you start from period 5. Because you always need 1 plus the seasonal period to start the forecast. Why? Because the first forecast, which is going to be from period 4, it will use components. I want to repeat that, component from the 3 seasons. So the 3 different periods prior to that, plus the seasonal index from period 1. It will use that. I want to repeat that. So if you want to do any forecast, you need the components. I want to repeat that, components from the first 3 seasons. But then the first 3 seasons, you can't even calculate anything because you need information from the previous one because you have only 3 periods. And then you also need a seasonal index for the first one. You need a seasonal index from period 1. And that's because if you subtract the number of the minimum data required from the number of seasonal periods, you're going to get 1. So it is only by month 3 that you now have enough data to be able to start from month 4 to do your forecasting. And that is why, and we've already said our idea, we shouldn't even have done, what do you call it? We shouldn't have done this seasonality for this data because this data is too small. We've already said that. And that's the reason why. Okay. So in the context of this, we do for period 4, period 5, and period 6. How do you do that? So we start from period 4. What is the formula? For period 4, you need the alpha multiply. Remember, we are calculating L4. Okay. You need the alpha, okay, and then you use the formula that we've been talking about all these while. So for the level formula, remember, information regarding the Y, it's for the current. Information regarding the level and the trend is for the previous. Information regarding the season is also the current. Okay, is that period. So if you want to find the L4, you need the information here. But then you need L3 in the past. And then you need a T3 in the past. This is what you get. Now, remember, I'm dealing with period 4. Okay, so if you go to period 4, Y in period 4 is 26. Alpha was given to us as 0.1. Sorry. Yeah, alpha is 0.2. Is it? Yes. Uh-oh. I think I mistakenly pressed there. Is the slide still showing?
Yes, please.
Yes, it's showing.
Oh, the slide is showing, but I can't see it in mine. You sure it's showing? Have I moved?
Yes.
Yes.
Okay. All right. So when you come here, you see that the formula says that you have alpha Y4 and then minus the S4 season. S4 season. Now, what is that S4 season? Now the S4 season is going to be that same one you had in the period 1 because it is using that information because you don't have the rest. You don't have because the rest could not be calculated because you didn't have enough data. So that's why you couldn't even have started from the first 3 period in terms of forecast. Now remember, we don't calculate these things for nothing. We calculate them only because we are going to calculate the forecast. That's all. And so now you start by taking that -5. And then 1 minus the alpha, which is 1 minus 0.2, giving you 0.8. Then you take the L3. We already knew the L3. It was the L1. And we find the T3. The T3 too was the T1 because we don't have anything. So we use that to be able to find this. And when you do that, you're going to get 26. When you simplify them, you're going to get 26. So your L1, L2, L3 are going to be the same value. Your T1, T2, T3 are going to be the same. Okay. Now, what about the T4 for the trend? Well, this is a formula. If you check it, you will know that you needed a beta. Okay, that one hasn't changed. You needed a beta. Then you needed a L4. What was our L4? L4 is the one we just found right now. So 26, you put it there. The beta is 0.3. It was given to you. So you substitute that 26 point that you got. What is L3? L3 was already the same thing up here, 22. So you substitute that. 1 minus the beta is the 0.7. And then you take the T3. The T3 is also exactly what you found here. You simplify, and that will give you 3.8 for the T4. That is a trend for period 4. Now we go to the season. To get a season, you need a gamma. Gamma was given to you as 0.1. It's up here. Okay. Then Y4. Y4 is a current period. Okay. That is a 26. Then you have L4. Okay. L4, we just find it up here. It's 26 point that. Then you have 1 minus the gamma, which is 0.9. And then you have S3. S3 is the same as the season that we have been dealing with, the -5 that we've already found. Okay. I told you the S1, S2, S3 is going to be the same thing we found. The what do you call it? The other ones are going to be the same thing that we found. When you substitute all of this, you're going to get -4.56. Now you add all of these, and that will give you a value of that. Now, I want to mention something here. Even though you have, and this is very important, even though you have for period, you are calculating the forecast for period 4, you are not using the and you can see this here. This, by the way, this value is wrong. This is supposed to be S4, not S2. When you come to finding this period, this F3, so let me just go back here and show you something. Why we didn't use the -5 as our value, and why we didn't also use this value. See, we found the S4 to be -4.56, but we still didn't use that value. Why? When we're adding them, we used the 3, the value of 3 for the S2. And that 3 comes from here. Okay. It comes from this S2 because the negative value cannot be used. And so the next important value is the S3. Remember, all of them qualifies to be the season that you are trying to calculate. So because in the addition towards the forecasting, you use any of them that is positive. And the -5, even though it helped you in the calculation, well, you were hoping that it will give you a positive value. It didn't give us a positive value. In fact, when you look at it here, it didn't give us a positive value. Okay, it gave us a -4.56. And so we'll take the original season 2 value, which was 3. And that is why we added a 3, giving you a value of forecast, which is 33.43. That is how you work this. And so you can do that same thing. Of course, when you do that same thing, you see that you're going to get this time to be positive already. So if it is positive, you use it. And then you can do for month 3, and then you can do for month 4. And when you do all of that, you're going to get to this value. So your forecast is going to be kind of truncated like this. Remember, as for period 1, there's no forecast. So your real forecast is going to start from here and that. Even though you see this -4 here in the season, is not used in the computation of the forecast period. Very good. That is how you do the whole of this. So what is the whole summary of this? I want you to get a summary before we go into the practicals, which you will do in real life. The first important thing to note today is that whenever you are doing forecasting, you select a method based on whether there is trend or there is season. So you ask yourself, is there a trend? If there's no trend or no season, then you go to a linear trend, okay, with no seasonal pattern. If there is a trend, okay, if there is no trend or no seasonal pattern, you use a single exponential smoothing. Okay. But if there is no trend and there is no trend, so if there's a trend but no season, use a Holt exponential smoothing. If there is a trend and a season, use a Holt Winters approach. Okay. These are the key things. In short, if there is a trend, if there's just a level, you use a single. That's it. If there is the level plus the trend in it, and of course, the STL decomposition will tell you. If there's a level and a trend, you just use Holt. If there's a level, there's a trend, and there is season, you use Holt Winter. Okay. But if there's none of these, okay, then you know, of course, there won't be none of these. There will always be like a level or something. Okay. Then in that case, the basic one can be used. But there's another way where there is, you see, this one here, there's a trend, but there's no season. Okay. You can also use regression. You can use the basic regression, the easiest one, which we shall do next time. So that is how you handle this. I'm going to just, in 5 minutes, now summarize everything using this Excel, not with the example that we did, but rather with the sample that I gave you guys. Okay, with the sample that I gave you. I need to close this so that I can show you the Excel. So I've given you this data set already. I'm just showing you just a little bit, a teeny bit of how you should treat it. Okay. So please go through this data because I'll give you a data set like this for you to run it yourself. So look at it. This is a data originally. This is a data. I'm not going to work it. I'm just going to show you how you should work it because the formulas are all there. This is a data set. This data set is basically just sales at this column here. And also you have time period. But you're also being reminded that this data, the time period can be split into quarters. Okay? And then if you have to deal with quarters, you know how to deal with it. If not, and you deal with year, you also know. But the actual time period is this T. So T is time. How do we now estimate the Holt Winter? First, the Holt. The Holt requires you to calculate the, let me make it bigger. The Holt requires you to calculate the level and then the trend. How do you calculate the level? Just take the sales, okay? The first one is going to be just the same value. So the L1 is going to be the sales. But then the L2 will use the formula that we have for the level, okay? Now this is the formula. The formula is taken, if you can remember, it was 0.3, okay? Alpha was 0.2, beta was 0.3, and then gamma was 0.1. So you take the 0.3, okay, and then 1 minus a 0.3 is a 0.7. And that is how you use to calculate the level here. And once you do it for this, you can just continue and double click and then you get to that of the rest. So this one too is using the same thing as the previous. It's using the same thing from the previous. Now, the time is starting with 0. How do you get to this first one? Again, double click this, and you will notice that it's taking the gamma, okay, to calculate the, what do you call it? To calculate the trend, you take this gamma, and then the opposite will be the 0.9, because 0.1, 1 minus that is 0.9. And then you can use that to take the E5. If you check carefully, the E5 is a level that you had. Remember, there was a level for the present minus the past level. Okay, so that's what you should see here, E5 minus E4. E5 is a 455, E4 is a red one, the 500. Okay, and then when you are done with that, then you take F, which is the time trend, the current one, which is the one before it, which was 0 before. Once you do this first one, the rest is simple. You just double click and you get all of these other values. Okay, all of them are taking the previous value. Then one step forecast is this. That is a forecast itself. It's just a matter of adding this to this. So when I come to this first one, you can see that I'm adding this one to this to get the first forecast. Not in the same horizontal line, no. You are adding the previous period to get this. The same thing when you go to this next one, you are adding the 2 to get it. When you go to the next one, you're adding the 2 to get it. When you go to the next one, you're adding the 2. I'll give you a data set for you to calculate all of this. As for the errors, and those ones, they are easy. Okay, to get this error is just the sales minus the actual. Okay, so you can see that the sales is 350. The actual is 500. So the error is negative 150. Once you do for that one, just move the cursor to this side, it turns to black. And once it turns to black, just double click, and everything will be populated nicely. Okay. So for example, suppose I don't have these ones here. Yeah, I just delete. Okay. I've deleted. Okay. All I do is I go to this one, the cursor turns black, double click, and everything is back. So all you need is just one formula, and just click and drag and drop, and then it will do all of the rest. Once you've done that, you can easily calculate the formula, the MSC. The MSC is simply going to be the average of all the squared ones. Okay. So if you come to the squared ones, the average of all of them will be the MSC. What about the root MSC? The root MSC is the square root, and then the others, which we have done, will follow. Okay. This is a graph of it. If you have to draw the graph, this is actual sales, and this is a one-step forecast. How do you do it? It's very simple. Okay? You can just come here. You can highlight this whole thing like this. Okay? Just highlight this, and then put the cursor on control, click on control, and go and highlight the whole of that. Okay? And also move. You're holding down the control. And then you now go to insert at the top, click on this insert line, and then choose the last but one. Okay, and that's it. Okay, and once you do that, you can just manipulate. You can even do a quick layout of how you want it to be. If you want to show this, show that. As you move the cursor, you'll be able to edit each one. But the key point is that you have the sales, and then you have the one-step forecast also showing clearly. That's how you do the hot winter. That's a hot winter. Okay, let me delete this because I've done the actual graph here so that it will look cool and nice.
But say, how did you get this graph? Which tool did you use?
The same Excel.
It looks too nice for an Excel.
Is what?
It looks too refined for an Excel graph. Maybe I'll come to you.
How to refine it.
Okay.
See, it is picking the series from the previous one.
Okay.
It's picking the whole series. I just have to tweak it, like I said.
Okay, all right.
It's the same one here, but tweaking it nicely to be able to do that. Okay. And of course, you can design it. Once you click on it and you come here, you can design it. If I go here, I can design it this way. I can design it that way. I can design it this way. If I even want a quick layout of them, I can have a quick layout of them the way I want. Okay. It's the same thing. Just design it different. Okay. Now for the hot winter, that one too, you need the following. You need the L, you need the T, and then you need the season. So watch this. This is interesting because that one, if I've even done the decomposition for you, remind me to give you this because I think I was playing with the decomposition with the Excel since you guys didn't want the Python. So I had to do the decomposition here. When I say STL decomposition, that's what I mean. The STL decomposition is this. You have to do this one separately, that one separately. So this data set contains trend, and then it contains season, and it contains residual. That's it. And you can draw all in Excel. Okay, you can draw all in Excel. But you just have to calculate the values and then use it to draw. Now, how do you find the L? Well, look at it. You jump these three because, again, I was using that same principle of starting from 4. Okay, so you just take this one, and this is another cool way. I was using the average approach. Okay, remember the L is the average. I don't know if you guys can remember. It's average. So here I took the average of the first 4, and that gives me this one for the L. Okay, and then after that, the rest is using the formula. But please note that I use the Holt winter, the multiplicative. Okay, you know the one that we did was additive. So here, instead of D8 minus 4, Gen 4, I just use D8 divided by Gen 4. That's all. Nothing else changes. Okay, just to say that, Masa, you have enjoyed too much of the additive. So let me just do the multiplicative. So that's what I did for this one. And once you do for the one, just double click. You click at the bottom right here, and everything will populate. I know you have this data. You just going to read the data with you. And then the rest is to get the time. Okay. So the time, you have the formula for the hot winter. If you check, you will notice that for the time. And then you do for this one too. Okay. And then you do for that one. The rest is just populating, all of them. What about the season? Now the season, that one, you see, if you can remember the season, we did a minus for the additive. And then for the multiplicative is we do the division. Okay. So if you take this one, you will notice that I am taking the LT, the sales divided by the LT. Again, is in the formula. Okay. And you can check that. And you do that for this, you do that for this. But when it comes here, you got to come, because these ones don't have these elements. That is why we use those. But when it comes here, starting from here, you got to use the seasonal formula. And if you check the seasonal formula, it is the same division sign that you are using for the multiplicative or winter. Okay. So just delete it and start all of them. Because of its time, I cannot use all. But you have the formula there to look at it. Once you are done with this, to get the forecast is easy. You just add this to this to this to this, you take that. Okay. You just add this to this to this to this, you take that. You just add this to this to this, you take that. You just adding them, but not horizontally, because the season starts from the first one. Once you are done with this forecast, if you want the error, it's just the actual minus the forecast. So you can see that the actual value here and the forecast. Once you got that error, you square that error, and then you can find the mean squared error for this. I also decided to draw this. Oh, you can forget about the fitting. I also decided to draw it here. And then you come and tell me that this one is 2 nines. Okay, it's the same thing approach. I don't know how you see it to be 2 nines. It's the same thing. And that's it. So learn how to compute these using this formula. Learn how to compute the Holt and the Holt winter in Excel. Learn how to compute the Holt and the Holt winter in Excel. Familiarize yourself with it. Give yourself another similar data, okay? And then practice it. Because, anyway, I'll give you an assignment to do that so that you learn how to practice it. Ladies and gentlemen, that brings us to the end of the entire caboodle.